So you might find yourself in a troubleshooting situation where you've got data that's not streaming. In some cases, it could take the form of orange wires. Orange wires means that no information is flowing through them for some reason or other. And in some cases, it might mean that information is prepared to flow through, but you need to tell it to. And that's called recompute. So the issue that I had, and let's see if it does it again for me, maybe it won't, but I made the determination that part of the trouble with us finding these weird eccentric, you know, if you've got circle issues like that where it's not falling on the centroid, I think part of that has to do with it communicating to two different streams of data at once. So in the sample that I had, I didn't quite try to filter both of them into one. So we're going to stick with just one side for now until I figure out how to do that. But so I went to disconnect this. And when I went to disconnect and disconnect all, here's what I ran into. This surface 4-point is on. It's not showing a surface, but it's on. And I turned the preview off and I turned the preview back on, and it doesn't show. I know that those triangles are there. And so what I need to do, because I did a disconnect, and it often happens paired with disconnecting information, you have to recompute the relationships in order to get them to show. So if you right-click in the middle of your workspace, and you go down to this, it's called recompute with a little play symbol. When you click that, it'll regenerate those relationships and try to bring back the geometry that you've disconnected.
So it's kind of like refreshing?
Yeah, it's like a refresh. Okay, so that's one of the first things you should try when you're troubleshooting something that you can't see, if you've done some disconnecting and modifying of a pre-operational, previously operational definition. Okay, so for our purposes, we're going to stick with, yes?
What are the steps for that?
Well, it's really just right-click and go to recompute. And the steps are more about, like, if you find yourself with something you know should work and you don't seem to see the geometry, try using recompute, because maybe it just means you disconnected something and it has to recalibrate it. Long-winded explanation, but you get the point. So we're going to just stick to one side with these surfaces as we move forward. And then we're going to, it should, if you guys stick to one side, it should work. So it should look just like this. You should have your area centroid off of your main triangles. And then you should have your surface center points. And then you should have your evaluate surface to find the normals. And then you should have your circle. And I think all of you got there. The troubleshooting part was eliminate all of the connection from down here, because that's going to mess everything up. Okay, so let's see. So this is what we're going to do. We're going to map a relationship into this. I think the radius is too large, so let's make it smaller so that you make it so that you can pretty clearly see that all of your circles are not going beyond the extents of that surface. Okay, for now. I'll show you what the troubleshooting part is for that later on. But we're going to create a curve that maps into the circumscribed edge of that triangle. Circumscribed? Inscribed. Inscribed. That's what I want. So there's going to be this kind of like weird circular, semicircular, elliptical shape that fits into it that meets the edge at all sides of the opposite triangle from where the circle is. And that would be these. No, I'm sorry, on the one that has the triangles, or the circles. So that would be these. So it kind of looks like this, and bear with me, because this one doesn't happen very often, and I only do it for this, but it's important to understand. Yeah, that's it, NURBS curve. So under the curve tab and under spline, there's this one called NURBS curve. And a NURBS curve is going to behave kind of differently than a few others, and I think, with your experience in Rhino, you're aware of that, right? So it functions off of I forget the terminology for it, but it's rather than having your curve follow along the points exactly, it's going to follow along, or I guess it's the average curve between 3 points or something like that is kind of the way it's described. Something like that. Iggy could probably tell you the dictionary definition. But so it asks for a couple of things. It asks for some vertices. It asks for the curve degree, which is going to be how accurate it is to the point itself, how tight. And then the period. I'm not exactly sure how to explain that, but it doesn't really come into play all that much except for the...
Just once.
It's not funny. So then we've got toggle that goes into that, right? Because it says false or true, right? So it's either going to be a periodic curve or a non-periodic curve. So let's just start building off of that backwards a little bit. I'm going to put it down here, actually. So we're going to start building off of that backwards. For the period, it's a binary toggle. It's going to either be true or be false. So when you go into params, this is a new one for you guys in terms of binary input. Boolean toggle is basically like a light switch. It'll say one is on, one is off, one is on, one is off. So that, if you double click, it goes to true, double click, it goes to false, and we plug that into NURBS. That was under param and input. All right. And it's going to ask for a set of vertices, which in this case are going to be the 3 points of the triangle. Okay, so we're mapping a curve within that triangle. So for us, it's going to be these points, those points, this point. Okay, and you see how it's starting to try and do that here? We've got it arching across, and it's trying to reach. So that's the behavior of a NURBS curve, right? It's the average curve between 3 points. And then we have the degree, which we're not going to modify. We can leave it at 3. But the toggle for us, we want to make it true. And look at what it did to that. Okay, so periodic curve is going to be inscribed, and a non-periodic curve is just going to stick with your regular definition of the average curve between those 3 points. All right, so here's where it's kind of weird. We still have a bit of an error, and that's okay. Sometimes you'll find warnings within your definition, and it might not necessarily mean that it's not working. It could actually just mean that it doesn't have all of the information to do everything it was designed to do. Okay, so in this case, we're not modifying, for instance, the degree, but you could. You could change the numerical value of the degree. In fact, let's play around with it for a little bit. So 0, less than 1, less than, say, 5. I'll plug that in. Well, it's only going to give us 2 or 3. Maybe we need a larger scale for that. Anyway, so that works. Let's move on. So this is what we want to do. We want to create a surface that is in between the circle and this periodic curve that's filling that triangle. Okay, so we're going to create a surface out of that, and on the other side, we're going to create surfaces off of the triangles on the other side. So it becomes really, really simple at this point. It's a command called boundary. One sec. Curve. Prim. I think. Curve prim. Yeah. So it's a command called boundary, and allow me to remember where this is. It's under surface, in freeform, boundary surface. Okay? So the boundary surface is going to take a set of curves or a group of curves, and it's going to create a surface between them, right? So it's akin to if you have these two curves modeled in Rhino, and it's going to say, you do the command planar surface. Well, that planar surface is going to find the relationship from one curve to the other, and it's going to fill it in with a surface. So for us, that would mean we need the curves from, where is that? Yeah, so that's the circle, right. Yeah, so we need the curves from the circle, and then we need the curves from the periodic curve. So we're going to plug that one in, and then we're going to take the curves from here, and we're going to plug that into boundary, and that's what we get. Oh, we need to be flattened, I think. Where do we need to be flattened? Yeah, there we go. All right, so flatten the output, because we have a non-flattened list going in, but flatten the output, and you'll get this relationship here, which is essentially the infill of those little tabs or coins or whatever you want to call them, donuts. And then the other side of the coin is we have these triangles. So as far as display is concerned, we're not baking this out into a model yet. We're still kind of sticking to Grasshopper. So what we're going to do for understanding what we've just modeled, we're going to assign a graphic display color to each of those components. And then we can hide everything else and really understand what it looks like. So what did we do before when we did a graphic display? We did a mesh. Okay, so the mesh can be simplified to a preview of a color. The reason I chose mesh is because meshes can then be modified further. But since I've now introduced to you those kind of cutoff commands, the preview is actually pretty nifty. And it's under display, and under preview, is it custom preview? Yeah. So custom preview asks you for two things. It'll ask you for the geometry, and then it'll ask you for the actual color or material or whatever it is. So the geometry for us, at least to start off, is going to be those surfaces, and then you'll do another one for the surfaces below. They're both showing up pink right now, but essentially when we go back into params and we grab a color swatch, we can change those colors. It looks really ugly right now, but we'll change it here in a sec. So white and red. Leave those on. You can turn boundary. Oh, let me set this up for you here. Display. Display preview. Surface freeform. All right. So when you go back and you start turning off some of these other surfaces that you don't want to see anymore, this is what you get. So you really start to understand visually what the objects are, so make sure you're hiding things, you can understand the gaps. So if this was some sort of a facade, now, with this kind of rendering technique, we have a real strong, firm understanding of what this facade actually looks like. Okay, so the real power here is you thought it was complicated to grab a warped surface and split it into panels. Well, imagine how complicated it would be to draw in each of these curves and then change your mind about how many cells you need to remap and then redraw it. So here is where it gets even more exponentially powerful. All right. So what I was saying about the circles and the size of those circles being smaller than the periodic curve that's going around, if you happen to have, and the same is true for creating a surface in Rhino, if you happen to have two surfaces or curves that you want to make into a surface, and they and if they cross each other in their profile, then you're not really going to be able to rectify which zones of that, which openings or which areas, subdivided areas, are going to be the surface. So here it creates a surface around the whole thing. Okay, so that's why you need it to be a certain width so that those circles actually get mapped in and they get cut out. If it's too big, like this one leaks over just a little bit, it's not going to cut. So if that happens, you got to go back over here to the radius and bring it down a little bit. Questions? Yes.
I need you to come over here.
Oh, okay. I'll be right there. Comments or concerns from anyone else? All right, so I'll be around to help you guys out.